Okay, part 2 of graphing sine and cosine. So at this point, you guys should be able to take this basic setup of a graph with a different period and a different amplitude, and then draw a basic picture of either sine or cosine. Sine going like this, and cosine goes like this. For example, maybe you had this graph that was a cosine. Has an amplitude of 2 up here because it goes up to 2 and down to -2. And then whatever this value is out here would actually be that period. So what we're going to do now is actually take and change those graphs just a little bit. So the red one here is the original. That's just a basic picture of a sine of x graph, this little curve S looking thing. If you put a negative out in front, if you throw a negative sign, whether there's a number there or not, if you put it out in front, all that does is it takes every maximum, every highest point, and it flips it over the x-axis, right? Here's the x-axis, the midline for right now. So there's the x-axis. Then over here, it also takes every minimum, every lowest point, and it flips it up to that point right there. So it's just doing a flipperoo. The intercepts don't change though, they won't be affected by it, so you leave those exactly as they were. Same with cosine. Red is the original, blue is the new one. So here's a maximum, boop, he became a minimum. A highest point flips over, becomes that lowest point. And then there's this lowest point, flips over the other side, and now he's the highest. Same here, and your intercepts don't change. So reflections are easy. You get your basic graph up there, and then you picture it being cut along this line right here, and you flip everybody over onto the other side, like it just did a little whoop-de-woo. So graph g of x equals negative cosine of 2x. So as always, we're going to start with our amplitude. Now the amplitude is the number out in front, and it's the absolute value. So our amplitude is 1, not -1. Okay, the period is calculated by 2 pi over b. This guy right here is b equals pi. Okay, and we're doing a cosine graph. So let's get some points put out here. Cosine starts at the maximum and it ends at the maximum. Now ending, it happens at pi. So there's our start and our end. And then halfway in between, so it's got to be this guy right here. It goes down to its minimum. And then our 2 intercepts. So there's our 5 key points. Now the graph would look something like that. But now let's go in and actually do that reflection. So this is going to be the reflected portion. I did the basic graph first, and then I'm going to come in later and do the reflection. So this guy up here was a maximum. Now he's going to flip down here and become a minimum. This guy right here flips up and goes to the top. This guy at the end was a maximum. Now he flips down underneath and becomes a minimum. And the intercepts do not change. So your final graph is this guy right here, the flipped upside down one. And when you graph these, you can put the 2 graphs on the same one. You don't have to erase one and then put the other. Put them on there. Just do do colors or make one darker than the other. Maybe draw me a note that says this is the final graph so I know which one's which. Using colors are much easier. So reflections, that's all that happens. Is all these top points become low points become high points, and the intercepts don't change. Okay, the other change that can be made is that we start shifting it. We start moving it up and down. So this time the blue one is the original. Here's the regular old cosine. And what's happened is that every one of these points has been moved from up here at 1 down 2 spots, right? This is 0, 1, -1. So I moved it down 2 spots. If you look at this point right here, he went down 2 spots. This guy this guy, and this guy. Everybody has moved down. Oops. So this has been shifted down 2, which makes the equation look like this. The new guy, this red one, is still y equals cosine of x, but then you put minus 2 out here on the end to show that it's been moved down 2 units, right, from 1 to negative 1, to make a new graph that's been shifted. Now over here in this one, we've got our basic sine starting out here, right? Period of 2 pi goes up to 1, down to negative 1, but then it's been picked up and it's been moved. So this point has now moved up to there, up 2. This guy, 1, 2. This guy, 1, 2. 1, 2. 1, 2. And it formed this new graph over here. So we've moved this red one up to here, formed a new one. It's been moved up 2. So the equation, instead of just y equals sine of x, we put a plus 2 out here. Plus for going up, minus for going down. Let's try one. So this says take the basic sine graph, okay? Starts here, goes up. Whoops. I didn't space it out right. Look at that. All right, I need to slow down. Let's start with the basic sine graph. We'll worry about the plus 3 later. Basic sine graph has an amplitude of 1, a period of 2 pi over 1, or just 2 pi, and it's the S one. So it starts at an intercept on the x-axis, and it ends at 1. Now, if my period is 2 pi, that means I need to go out here to 2 pi to put my end, and then exactly halfway in the middle is where my other piece goes. Okay, now I can figure out my maximums and minimums. The maximum happens between the first 2 dots at the amplitude. The next one, the minimum, happens between the other 2 dots, and it's a minimum. Okay, there's the original sine of x. Then you come along and you're going to take every one of those points and you're going to add 3 to them, which just means to go up 1, 2, 3. Okay, this one right here, go up 1, 2, 3. This one right here, 1, 2, 3. 1, 2, 3. And 1, 2, 3. And you connect those dots. And that is your final graph. So graph the original, no problem, no sweat, we've practiced those. And then going to make the change by either moving the dots up or down, or maybe you had to reflect. This moving up and down should happen last. Should be done last, after everything, after reflections. If you move it before, then you'll end up reflecting it the wrong way. All right, let's try another one. This time it's sine of 4x. So again, amplitude starting out, let's do a different color. Our amplitude is 1. Our period is going to be 2 pi over 4. That's our b right there, which is pi over 2. Okay, we're doing sine. Now I am just graphing this portion of it right here. I'm not even worried about what that minus 1 does to it. I'll deal with that at the end. So this will be done later. What happened to my, I did not happen to it. Let's go back to orange and draw this basic guy. So we're at sine. Starts at the x-axis, ends at the x-axis, and we gotta go find pi over 2. So here's pi over 2, that's where it ends. Halfway in the between is another intercept. And then at the other point in between the 2 dots is a maximum. In between the other 2 dots is a minimum. Okay, there's my beginning sine of 4x graph. Got to come in and do that, moving it down 1. That just literally means take every point, scoot it down 1, down 1, down 1, down 1, connect the dots. And that is my final graph.